So here we go. In example 2, we're going to find all solutions, and we're going to stick with radians. Okay, so first thing I want to do is I want to solve for cosine of 3x. So I am going to divide by square root 2. So I get cosine of 3x equals 1 over square root 2. Okay, we're going to rationalize this. Square root 2 over square root 2. So cosine of 3x equals square root 2 over 2. Okay, again, think about this. This 3x is changing the period so that it will complete a cycle in 2 pi thirds. Okay, because I take my period 2 pi and divide it by 3. So if we think about that, if it's splitting up into 3 periods, and we normally would get 2 in a 2 pi period, I should get 6 solutions. This is just tripling the number of solutions. Where on that first video we had 2 alpha, and that doubled our number of solutions. So let's look at this. We're just going to ignore this 3x for a second. We're going to put 3x equals, and then where is cosine square root 2 over 2? Well, cosine is square root 2 over 2 at pi fourths, and we know that's going to happen every 2 pi n. Every 2 pi n, I am going to have a coterminal angle with the same square root 2 over 2. Okay, then if I look at my other one, cosine is square root 2 over 2, well, that's negative, so 7 pi fourths plus 2 pi n. Okay, so we've got our 2 from our unit circle that fit between 0 and 2 pi. This one is actually finding all solutions. So these would be all solutions if this 3 did not exist, if we were just solving for cosine of x. Okay, but because of this 3, we are going to times everything by a third. We're going to get x by itself. So then I'd get x equals pi twelfths plus 2 pi thirds n, and x equals 7 pi twelfths plus 2 pi third n. So these are going to be all solutions. Okay, this is going to get every single one of them. If you notice, here's the period of 2 pi thirds, and by timesing by 3, this now became 1/12. If I was to actually find all of them between 0 and 2 pi, I should find 6 solutions. Because it asks for all solution, we give the equation. Okay, let's do one from your assignment. Let's do number 5. Okay, so this is number 5 from your assignment. So 5 cosine of 4 theta plus 2 equals 0. So again, we're going to find all solutions in radians. So I'm going to minus the 2. So 5 cosine of 4 theta equals negative 2. Divide by 5. Cosine of 4 theta equals negative 2/5. Okay, first off, is this a good ratio? Well, cosine is adjacent over hypotenuse. This is good. Is it on our unit circle? No, but we're okay with that. So what we're going to do is we're going to go cosine inverse of negative 2/5. So we need our graphing calculator, or calculator, which I need to find mine real quick. And I got it. Okay, haven't pulled it out yet today. If we pull out our calculator, we're going to first make sure we are in radians. Okay, so I'm in radians. I'm going to go second inverse, or arc cosine of negative 2/5. So we're going to get 1.9823. Okay, we're going to do 4 decimal places. Okay, so that tells me if I was just solving for theta, cosine theta equals -2/5, theta would have equaled 1.9823. So we know from the unit circle that there are two solutions, right? For every cosine sine, there's going to be two solutions, 0 to 2 pi, and they're always 2 pi away, so they don't have that nice steady pattern to each one. So if I was to draw this, okay, 1.9 would be, I don't know, what quadrant would that be? Okay, cosine was -2/3, so it would be maybe about here, give or take. Okay, so if it's clear over there, we know cosine. All students take calculus. So cosine was negative. That's why I kind of guessed it was 1.9 was over in this quadrant somewhere. Okay. If we find our reference angle, that's going to be pi minus 1.9823. So this reference angle right here is 1.1593. Okay, so if we look at that, we know cosine is going to be negative in quadrant 2 and quadrant 3. So my other spot is right here with the same reference angle as this one right here. Okay, so they have the same reference angle. So this is also 1.1593. So I could take pi plus 1.1593. Oop, having troubles. Oops. And I would get my other angle, so alpha also equals 4.3009. Okay, kind of confusing, but we've got our two solutions. But we're not done, because we solved for theta, but we needed to solve for 4 theta. So 4 theta equals 1.9823 plus 2 pi n. Okay, we're going to times everything by a fourth. So theta equals 1.9823 divided by 0.4956 plus, okay, pi halves n. Okay, if I divide that by 4, that'd be 2 pi fourths, which is pi halves. Okay, so there's one answer. And then my second answer is going to be 4 theta equals 4.3009 plus 2 pi n. Okay, dividing everything by 4 or timesing it by a fourth, your choice. And we're going to take that, divide it by 4. We get 1.0752 plus pi halves n. Okay, so we should have our two answers. So theta is going to equal 4.956 plus pi halves n, and theta equals 1.075 plus pi halves n. Okay, this one's a little trickier because it wasn't on the unit circle, but the process is the same. This is what we did on Wednesday. If you're confused about this or you have questions, please let me know, and I will make videos on any of the problems or discussing it as much as you need. Okay, So I'm going to do another video. We're going to do a few more, make sure that we've got this. I'll do a couple more from our assignment, and